Hey guys, in this hyper video, we're going to introduce you to some basic aspects of ECG. But first, let's recall the electrical conduction system of the heart, adding just a little more flesh to the bone. Remember that the electrical conduction system of the heart involves autorhythmic cells and nerve fibers which generate and transmit timely action potentials through the heart. This facilitates stimulation of myocardial cells to contract, with the end result being the heartbeat. Electrical impulses will be generated by the cyanoatrial node or SA node. This is the pacemaker of the heart, normally generating 60 to 100 action potentials per minute. Sounds familiar? Exactly. This corresponds with the normal heart rate of a healthy human, 60 to 100 beats per minute. The cyanoatrial node is found within the right atrium, just below the superior vena cava. Once its impulses are generated, they will be spread along three internodal tracts, anterior, middle, and posterior, in the right atrium, and one Bachmann's bundle to the left atrium. All of this facilitates the simultaneous contraction of both atria. The internodal tracts from the SA node converge onto the atrioventricular node, also referred to as the AV node, which is found right above the AV valves. The AV node is the gateway which generates and transmits impulses through the interventricular septum so that impulses can pass from the atria to the ventricles. So, the AV node transmits impulses through the bundle of His, which lies within the interventricular septum. The bundle of His, however, does not wait too long to split into two bundle branches, one going right and the next going left. So you have a right bundle branch and a left bundle branch. Now guys, make note of these structures, because in the discussion of pathologies, you will start hearing about right bundle branch blocks and left bundle branch blocks, which are sources of arrhythmias. From here, the bundle branches give off several Purkinje fibers, which spread throughout the myocardium of the heart. This facilitates ventricular contraction. We will now delve into some of the basics of the electrocardiogram. Now in a perfect scenario, the heart oscillates like this: electric impulse, contraction, electric impulse, contraction, and so on. However, when something goes wrong with this pattern, we need a way to visualize the electrical activity of the heart as physicians. How do we do that? Perfect. Using an electrocardiogram, better known as the ECG or EKG, the practitioner will place electrodes on specific areas across the body in order to measure this electrical activity. Question: why do you think electrodes can be placed superficially across the body and we don't have to cut open the person? Well, for one, practicality, and two, the body is filled with fluids that contain electrolytes, and therefore the body can function as a volume conductor, transmitting electrical waves towards the superficial surfaces.